Let's prove that a parallelogram is a rhombus if and only if diagonals are perpendicular to each other. We got a rhombus. Let's call it O, A, B, C, whereby OA must be equal to OC, that's a rhombus, and OC, AB are parallel to each other, and OA and BC are parallel to each other. Once again, OC is parallel to AB, and OA is parallel to CB. And they are parallel, and magnitude of OC is equal to magnitude of OA. Let OA be represented by A vector, OC be represented by C vector. Now we want to show that if OABC is a rhombus, then the diagonals are perpendicular to each other. So let's draw the diagonal. So we draw the diagonal OB. And then the diagonal AC. And we observe that angle between those diagonal is exactly equal to 90 degrees. But this is not about observation, this is about proving. We need to prove that angle between OB and AC is exactly equal to 90 degrees, and we will be proving using vectors. Now let's recall the triangle law of vector. By triangle law of vector, by triangle law of vectors, moving from O to B, that's the vector OB, is same as moving from O to A and then moving up to A to B. After all, initial position and final position will remain same. You will just reach to B. Whether you move directly from O to B, that is same as reaching from O to A, then to B. You take a different path, it doesn't matter. Your objective is to reach B. That's what triangle law is. So the diagonal OB equal to OA plus AB. That's equal to OA is equal to A, but OABC is a parallelogram, so opposite sides are parallel and opposite sides are equal as well. Now two vectors are equal if they are parallel, they got the same direction and they got the same magnitude. Vector is identified just by magnitude and direction, so AB must be equal to C vector. Okay, we got the diagonal OB in term of A and C. Can we get the diagonal AC in term of A and C? The answer is yes. Again, by triangle law of vector, in triangle OAC, moving from O to C, we are basically reaching the point C. We can reach it directly from O to C, or we can traverse through A and reach C. OA plus AC. OA plus AC. We can reach C by traveling through A. That is OC C vector equal to OA. OA is A vector plus AC. From there we observe that diagonal AC equal to C minus A. Let's call this one to be equality 1. Let's call this one to be equality 2. By equality 1 and 2. Once again, by equality 1 and 2, OB equal to, one diagonal OB equal to C plus A, other diagonal AC equal to C minus A. we want to show that diagonals are perpendicular to each other. Now we know that if dot product of two vector is 0, then if dot product of two vector is 0, then those two vectors are perpendicular to each other. Let's find dot product of OB and AC. OB dot AC, that's equal to C plus A dot C minus A. We know that dot product is distributive, so we can write this as C dot C minus A plus A dot C minus A. That's equal to C dot C, again dot product is distributive, so C dot A and then A dot C minus A dot A. Now we know that dot product is commutative. A dot C is equal to C dot A, so you can cancel it out. So far we just used the fact that OABC is a parallelogram. Once again, we simply use the fact that OABC is a parallelogram. So far we did not use the fact that OA equal to OC, adjacent side of a rhombus, are equal. Let's use that. C dot C equal to C square and A dot A equal to A square. That's simply because A dot A equal to magnitude of A times magnitude of A times cos of angle between those. Angle between A and A is 0 degree. So magnitude of A square, that's just A square. Now C and A, that got to be equal. Magnitude of OC must be equal to magnitude of OA because it's a rhombus and adjacent side of a rhombus are equal. So the difference equal to 0. So OB is perpendicular to AC, or the diagonals are perpendicular to each other. Diagonal of a rhombus must be perpendicular to each other. So we did one part, that diagonal of a rhombus must be perpendicular to each other. OABC is a rhombus and we find that diagonals has to be perpendicular to each other, and we proved it. How about the converse? Conversely, let's draw diagonal that are perpendicular to each other. And let's draw quadrilateral such that diagonal bisect each other. So quadrilateral will be a parallelogram. Once again, we want to draw a parallelogram with diagonal being perpendicular to each other. Alright, we got a parallelogram with diagonal being perpendicular to each other. We want to show that it is a rhombus. Once again, OABC is a parallelogram. Conversely, OABC is a parallelogram with diagonal AC perpendicular to OB. We want to show that OABC is a rhombus. Once again, let OA be A vector, OC be C vector. Once again, OA be A vector, OC be C vector. Parallelogram. In case of parallelogram, opposite sides are parallel and equal in magnitude, so AB must be equal to C vector. Again, by triangle law of vector, OB will turn out to be A plus C, and AC will turn out to be C minus A. Let's write it down. By triangle law of vectors, by triangle law, OB is equal to A plus C, and then AC equal to C minus A. Since OB is perpendicular to AC, since OB is perpendicular to AC, OB dot AC is simply equal to 0. So, OB is C plus A, addition of vector is commutative. So, C plus A is same as A plus C. AC is C minus A, C plus A dot C minus A equal to 0. Again, we apply distributive law to obtain C dot C minus A plus A dot C minus A equal to 0. Again, we apply distributive law to say that C dot C minus C dot A plus A dot C minus A dot A equal to 0. However, in case of vector, dot product is commutative. So, A dot C is same as C dot A. So, negative positive will get cancelled. C dot C is simply C square. A dot A is simply A square. So, we can say that C square equal to A square. From there, we conclude C equal to plus minus A, but C and A being length of the vector C and A, that cannot be negative, so C has to be plus A. So adjacent side of the parallelogram are equal, so parallelogram is a rhombus. So these two sides are equal, so the parallelogram has to be a rhombus.